Okay, so let's talk about quadratic equations and graphs. So this is now chapter 5. Last chapter and chapter 3, so we had quadratic equations. So we learned how to expand, simplify, and factorize quadratic expressions. So for this chapter, we're going to um, get the answer from quadratic equations. And then later on in this chapter, we're going to graph quadratic equations. Okay. So what are we going to learn in this chapter? So we are going to solve quadratic equations by factorization. Okay, sorry for my little typo here. So next is to solve mathematical and real-life problems involving quadratic equations. And number 3, we will draw graphs of quadratic equations or functions. And lastly, we're going to state the properties of the graphs of quadratic equations. Okay, so let's first identify again what are quadratic equations. Okay, quadratic equations are simply quadratic expressions with an equal sign. Okay, so again, the square here makes it a quadratic. So without this square, so this is simply a linear equation. So it basically creates a straight line, wherein quadratic equations creates curves. Okay, so we're going to learn those things as we progress along this chapter. Now, there's a standard form for quadratic equations in the format of ax squared plus bx plus c is equal to 0. Now, where a, b, and c are numbers for this example here. So what are the values of your a, b, and c? Now, so a here is 5, b here is 3, and c here is another 3. And take note again that a cannot be equal to 0 because if this x squared here disappears, this is not a quadratic equation anymore. It's just a linear equation. Okay. Again, this square here makes this a quadratic equation. So now, quadratic equations, sometimes these guys, or in some books, they're not written as this. Okay. They don't give away the standard form that easily. So sometimes they write it in different ways. So let's have three examples here. So the first one, so we have x squared is equal to 3x minus 1. So how do we transform this in standard form? Okay, so basically we move 3x to the left side, we move negative 1 to the left side, okay, and it becomes x squared minus 3x plus 1 equals 0. Remember that quadratic equations are always equal to 0. Okay, that's what makes it an equation. Okay, so therefore, your a here, given this equation is 1, and then your b is negative 3, and then your c is positive 1 or simply 1. And then let's have another one. So let's have 2 and then w squared minus 2w equals 5. So how do we change this to the standard form? So we just basically expand by distributing 2 to both twice. I mean w squared minus 2w. That's why it becomes this one, 2w squared minus 4w minus 5. So your a is equal to 2, b is equal to negative 4, and c is negative 5. And then lastly, so let's have z times z minus 1 equals 3. Now, it doesn't say that if you don't have a visible square, it's not a quadratic. This one is a quadratic. But how? Well, basically, you need to distribute a z to z minus 1. So therefore, you get this. So z squared minus z minus 3 equals 0. And then you move 3 to the left side. So your a is 1, your b is negative 1, and then your c is negative 3. Okay. Okay. So again, uh, linear equations create lines. Okay. Now, before, when you were in Sec 1, you're given x plus 3 is equal to 5. We know that x is equal to 2, okay? Now, linear equations only give us one answer, okay? How about quadratic, wherein everything is x squared? So that means that we will have two values for x, okay? And then the question is, how do we look for those values? Okay, but before we go there, okay, so let me share you some terms, important terms. Now, in some books, they call this answers solutions. Now, in other books, they call them roots. Okay, it depends on what book are we using. Okay, especially when you go to A maths, they will be called roots, but basically they're the same thing. Okay, now let's go. Now, how do we solve quadratic equations? Now, for this set of examples, um, we don't have to factorize anything because these questions here are already the factors of a quadratic equation. Okay, so therefore, so we just need to equate both factors to 0. So what do I mean by that? So you have x as your first factor for letter A, and then x minus 1 as your second factor for letter A. And now, to solve for the values of x in a quadratic equation, you need to equate x and x minus 1 to 0. So x is equal to 0, and then x minus 1 is equal to 0. So the values of your x are 0 or positive 1 or 1. That's it. Now let's have letter B. Now for letter B, so you have 2x and x plus 1 is equal to 0. So 2x is your first factor equals 0, and then x plus 1 is your next factor equals 0. So solving for x here is equal to 0. Okay, again, how did it happen? So when you remove 2, you divide both sides by 2. So x is equal to 0 divided by 2 is 0. And then this one, you just transpose x plus 1. So therefore, your answers or the values of your x are 0 or negative 1. Okay, now let's proceed to letter C. For letter C, we have now x minus 2 and x plus 3. So we get x minus 2 equals 0, and then x plus 3 equals 0. So solving for x is equal to 2, and then the other one is negative 3. So therefore, the values of x are 2 and negative 3. How about letter D? So we have 2x minus 3 and 3x plus 5 equals 0. So 2x minus 3 equals 0 here. Solving for x, so bring down 2x equals, and then transpose 3 here. And then, so therefore, x is equal to 3 over 2. Now for the other one, 3x plus 5. So solving for x, so transpose 5, it becomes minus 5, and divide by 3. So x here is negative 5 thirds. Okay, so the values of your x are 3 over 2 or negative 5 over 3. Now take note, in algebra, you don't have to express in mixed number or even in decimal. Okay, we accept improper fractions. Okay, so that's it. Those are the values of x. Okay, and then for this set of questions, you need to factorize this now. Okay, so let's have letter A. So letter A, so we have 2x squared plus 6x is equal to 0. So how do we solve for the values of x? So observe your equation. Okay, so you have two terms. Okay, now if you think of the identities that we had last chapter, the first thing you need to ask yourself is, okay, are both of these perfect square? So obviously they are not, right? So because it's 2 and 6. So next thing, if it's not perfect square, okay, is there a common factor between 2x squared and 6x? Yes, 2 and 6 are divisible by 2, and then you have x squared and x. But then we only choose the one with the lowest index, so that is x. So 2x is your common factor. And then what do we do next? we divide each of this term by 2x. So 2x squared divided by 2x, so 2 is cancelled out. So x squared divided by x, that's why you have x here. And then 6x divided by 2x, so 6 divided by 2 is 3, and then x is cancelled out. So now, these are the factors of this quadratic equations. And then, so we just repeat again what we have learned from the previous set of examples. So 2x equals 0, and then x plus 3 equals 0. So this is basically 0, and then the other one is negative 3. So therefore, my answers are 0 or negative 3 for letter A. Now, let's have letter B. Now, obviously, for letter B, again, you have two terms, and then first thing you need to ask, are they perfect squares? Are both of them perfect square? So yes, it's both of them are perfect squares. So this is an identity. So what do we do? So you prepare your two brackets, and then you just get the root of both terms. So the square root of 9x squared is 3x and another is 3x. And then the square root of 4 is 2 and another negative 2. So these are the factors of your quadratic equation here. So 3x plus 2 equals 0, and then 3x minus 2 is equal to 0. So those are our two equations. So solving for x here, so bring down 3x and then transpose 2, you have negative 2, divide by 3, so therefore x is negative 2/3, and then the other one, so bring down 3x, so transpose this becomes 2, divide by 3, so x here is 2/3. So your answers are 2/3 or negative 2/3. Okay, so those are your answers for letter B. Now, how about for letter C? For letter C, okay, now you have three terms. Now, first thing you need to ask yourself is the first and then the third term a perfect square? Okay, if you're talking about identities here, special identities, they're not, right? 28 is not a perfect square. So what is the next uh, factorization technique that we should apply if we have three terms? Okay, so this is by guessing and checking. Okay, so we need to factor out x squared, which is x and x. And then what are the factors of negative 28 that when we add them, your answer is a negative 3. Okay, so we have listed down everything here. So our answer is negative 7 and 4. Because negative 7 times 4 is negative 28, and negative 7 plus 4 is a negative 3. So that means that these are the correct pairs of our factors. So we get x minus 7, so x minus 7, and then x plus 4. So these are the factors of your quadratic equation. So equate both factors to 0. So x minus 7 equals 0, and then x plus 4 equals 0. So the values of x are 7 or negative 4. That's it. And then lastly, for our last example, let's have 2x squared plus 5x minus 12 equals 0. So again, you have three terms, and 12 and 2 are not perfect squares. So since a here is greater than 1, that means that we can only answer this by guess and check method. Okay, so what are the factors of 2x squared? So 2x and x. And then what are the factors of negative 12? Negative 3 and 4. Now, I know that there are a lot of factors here. Okay, but then our correct pair is negative 3 and 4. Now, what we're after here is that, again, when we multiply the inner and outer, we're supposed to get 5x. Okay, so let me show that. Let me move this here. Okay, so 2x minus 3, and then I have x plus 4 here. Okay, so how do we check if the answer is correct, if our pair is correct? Now, when you multiply the inner, okay, This is negative 3x. And then when you multiply the outer, this is 8x. So the sum of this is simply 5x. Now, again, if this is the same with our middle term, that means that this is the correct pair of factors for this quadratic equation. So therefore, okay, let me just undo some things. Okay, so therefore, this is your answer. Okay, so we just need to equate each factor by 0. So 2x minus 3 equals 0, and then x plus 4 equals 0. So solving for x, so transpose 3, so it becomes 3, and then divide by 2. So your answer is 3 over 2. And then for this, basically x is equal to negative 4. So therefore, your answers are 3 over 2 or negative 4.